Okay, welcome to the next video. In this video, I'll briefly be talking about some useful and just cool packages for geospatial analyses and also beyond. It's just like a bit of a collection of cool packages, mainly in R, for working with geospatial data. And you can already see like in this cool animation, which the package for this will actually also talk about. We'll see how many of these we can use in the practicals, but if you're interested in any of these, you can always read up on them yourself. Or also just talk to us. If something really stands out to you, we're always happy to adjust the course a bit to take it into account. So I was briefly talking about overpass in the previous video, which hopefully you saw. And I said already that there's an R package for this, and that R package is called OSM data. So that package really makes it quite easy to just, similar to the web UI I showed before, to basically create these queries with an even simpler format, or query format in R, and then download the data. And then, for example, here you have some quick snippet on how you could use this, how to query the Overpass API, which has OpenStreetMap data, of course. So here I'm using some R packages, the OSM data package mainly. SF is just for like working with map data. And ggplot2, of course, to create the plot in the end. And what we do here is that we just create this query for Amsterdam. Then we tell it what we actually want. So here, for example, we want a feature, which is bicycleways. Again, this is just the lingo of like highway, cycleway. Like this is kind of what we would look up in the OpenStreetMap wiki. And then we run this query, put the data into a geom_sf. So this just plots spatial data, and then we show this and have to use the right coordinate system. Again, some new things, we'll talk about this in the in-person class in detail, so don't worry about it. But the cool thing is that like we basically have like 10, 15 lines of code here, and suddenly we plotted literally all the cycleways in Amsterdam, which to me is like actually really impressive. And I think I previously tried this with Munich, and then it just didn't look so nice. So that's why I switched back here to Amsterdam, even though it might seem a bit arbitrary. Next up, we have Leaflet, and this package we'll definitely use. So if you're curious, you can already have a look at it. And what Leaflet allows you is to do some very simple and easy plotting of interactive maps, and even beyond. But you can just put up a map itself, and the nice thing is that, of course, not in this PowerPoint presentation, but if you do this in R, this map will be interactive. So basically, like Google Maps, you can like zoom it, you can move it, and you can add points to it, like this one, and you can use data here to show these points. So you could, for example, also mix this with the OSM data tool that I just showed before to kind of plot data on there, and then interactively explore where these points lie. For example, we could put the museums here that I talked about earlier. Again, you can freely pan and zoom the map. And there's different layers. So if you have something more colorful you want to put on top, you can use a black and white layer to show the map like a bit more, less intense. Related to this, and a slightly even cooler package, I guess, which under the hood also uses Leaflet sometimes, is tmap. And the idea with tmap is to just really allow you for like very simple mapping in R. And it kind of is an abstraction on top of even Leaflet, to make the creation of map-based visualizations even more easy. And what you can, for example, do is here, again, some very simple example code. What we did here is that we used the world data set that is included with tmap. Then we briefly render the world itself, and then on top of it we show a so-called choropleth, which is just kind of a heat map, or a plot that has in the color code kind of defined what value something has. So here, for example, we're plotting well-being, and the darker shade of green we have, the higher the well-being is. And again, we can see that this plot here was created in, again, I don't know, 8 lines of code or something. So really impressive and cool that you can just create this whole map of the world and highlight how well-being is in different areas with so little code. And you can do even beyond, go even further. This is really, I think, why I like TMAP so far, is that by just adding one line of code, we can actually make this an interactive map. So it has kind of two modes of like either being static for if you want, for example, a paper or like your, I don't know, report to have a graphic in there. But you can also, if you have a HTML output, you can make it interactive. And then again, you see these leaflet tools. So which this is Powered by Leaflet, to kind of scroll around in there, zoom in, out, which is really, really nice to better understand your geospatial data. Next up, we have the H3 package, which stands for Hierarchical Hexagonal Index, which kind of cuts the world into tiny slices. So this was developed by Uber, and a matching R package has been developed already, so it's easy to use for you. And what this does is that it takes the whole world and kind of cuts it into many teeny tiny hexagons. And what this allows you is to use these hexagons then to do aggregation. So for example, now we can count how many museums are in each of these hexagons. And then that way we can compare, for example, how dense this is maybe in Munich versus Amsterdam or some other area. And the reason for this is that, of course, if we just use city bounds, these might be very different in size, right? We could have like a really big city, we could have really small cities, and sometimes we want to account something for the city, but maybe sometimes we also just want to do something across like the whole of Germany. And then, yeah, maybe if you would do it on like state size or something, all the states would have different sizes. So this is actually like a really fair way of slicing something up into hexagons, and then looking at, for example, how many events or something fall into each hexagon. There's so many ways you can do things with this. Also, for example, earthquakes or something, which is a classic geospatial data. You can just see how dense these are across the world. And the nice thing with these hexagons is that they're also kind of nested. So you can see here, you have the big ones, and then you can get smaller and smaller, and you can really, there's very, very many different levels of how small you can go in here, which is just so nice. And again, yeah, this uses hexagons, and the reason for this is just that they have some really nice properties to them. You don't need to think about it much further, but basically that these like equidistant to their neighbors, which is not really the case with like squares or something, right? The diagonal squares are further away, and with hexagons, all of this just works out really nicely. Still, if you want to do something with squares, there's tools for that as well, and then it's called S2. Just because, yeah, like it might seem very arbitrary to you to highlight this sort of package, but actually if in practice you want to work with geospatial data and with like some points or something, very often actually you end up having to use some form of aggregation on a spatial level, and then having these indices like either the H3 or the S2 suddenly makes this problem like much more palpable, and like easier to work with. Next up, and we're getting to the end of the list, we have RayShader. So this is the cool package that created the visualization in the beginning on the title slide. And this just basically allows you to, yeah, beautiful, to create like beautiful geospatial rendered plots. Even for normal ggplots, this actually works, but it allows you to do 3D rendering of plots. And of course, if you have, for example, something like elevation data for mountains, this works out actually really, really cool. But it can also be useful for, yeah, just a normal ggplot where you want to show something in 3D. It really depends on the use case, but it's a very powerful package. And I'm still amazed that, I mean, you can just do these things in R. I think that's really shows just how flexible of a language this is, right? Yeah, and again, it can do so many things. And we'll probably won't have time to focus on this package in detail in the course. Next up, there's GeoFacet, which I think is also quite a cool package. And what this allows you to, we've already talked about facets in ggplot in the previous course. If you haven't heard about facets in ggplot, I also would really recommend you to check them out. It's a very powerful feature. And what you can do with GeoFacet is that you facet plots and it takes geospatial data into account. So typically this would be on the country or state level. And then it comes with pre-made locations. And then you can kind of show graphs, tiny subgraphs, which are called facets in ggplot already. They exist. But with this package, you can put them on a location that makes semantic sense. So here, for example, we have a plot of Europe. And unfortunately, I forgot what actually, we can see on the y-axis, there's the GDP per capita. And we can see here that for each country, we get like its own plot. And the location of the plots is kind of, it makes sense on the big scale of Europe, right? So Germany is really in the center here. Then we have France down here. And of course, it's a bit of an oversimplification, like this is not exactly where the countries lie, but it's roughly where they are. So it actually makes it really easy to understand the plot. If you're looking for Italy, you look at the bottom, of course. You have Luxembourg in between. So all these countries are roughly where you would expect them, which makes the plot much easier to read. And the package is very, very simple to use. You basically just tell it which variable has the information that you want and then which kind of grid to use. And it can create these really cool plots for you. Yeah, that's it in terms of these packages. Some of them will dive in a bit deeper in the practical and of course also in the graded exercise sheet. And besides that, here's the information on the graphics I've used in this video. And then I will see you on Friday. Looking forward to it.